Back to the channel. Today we're solving August 2nd problem. Minimum swap to group all ones together. Second. Um, it's been a long time since I updated, so I'm gonna just catch up and make a lot of videos today and setting up. So for this question, we try to match all the group all the ones together, and then we consider this is a circular array where the first element and the last elements are adjacent. So if you look at example 3, 1, 1, 0, 0, 1, all the ones are actually together because this is a circular array. And then we want to find that the minimum swap required to group all the ones together. So for this case, we can either move this one to here or move this one up here. So making it to be all one together. And then for this, we see there are two zeros in between. So we can either move this 2, 1 up or this 2, 1 to this space. So at this point, do you guys have any idea what algorithm to use? So one thing I can think of is that when we have 3 ones, right, we actually just want to look at any of 3 random spot and see how many ones there are. So if let's say I look at this, I only have 1 1, and then I require 3 ones to be grouped together, and I know that they require at least two swap to get here. But when I look at this chunk, I'm like, oh wait, actually I already have 2 ones, right, and 1 empty spot. So I just need to swap the 1 into here. All right, so let's see if I can visualize this one. So, all right. So for example, in the beginning, you have like 3's ones, so that you know your window size is gonna be 3, right? So first you look at this and then you're like, oh, I have 1 1. So my mean swap. So you initialize something like mean swap, and then you set the mean swap need to be 2, right? And then you move on to the next one, right? You move on to this chunk, and then you set, oh, my minimum swap now only need 1, and then you update this to be 1, and then you keep doing this one, and then doing this one, and then doing this one, so you can see the minimum swap is actually 1, right? But we also need to consider the case where this is a circular, right? So there's actually 0 at the back, 1 at the back, 0 at the back. So I'll give you another example for this, and then you can see. All right, so this also have 3 ones, so I know that the sliding window size need to be 3. So first look at this, and then I was like, oh, my min swap need to be 1, right? And then I moved on to this one. Oh, it's a bad drawing. Okay, move on to this one, and then I said the min swap is 2, but then since the minimum is 1, I didn't update it. And then I move on to, let me just use another color. Move on this is also 2, it doesn't matter. So here's the point where when we have this at the end, we actually want to check the length going onward, right, until I reach this and the desired size. So I keep going, and then here it said 2, here it said 1, and then at the end this one is actually 0, so you update it to be 0. So for the sliding windows, we want to make sure that we start and the start and then end at the end plus the desired size, right? So one last example, I don't know why I put it here. Okay, so for this one, you can see that this is actually like 4 1, so your desired size need to be 4. And then you can see, oh, wait, you need to put 2. But there's a case where this is a circular, right? So you actually append 1 at the back, so 1 1 0 at the back. So you actually can see that this size or this size is actually will give you a mean swap, which is 1. So that's a case where we need to consider until the end, because we we consider the fact that this can be a circular array. All right, so let's dive into the code. So in the beginning, I will just define mean swap equals to the infinity. You want to make the maximum value, and then you can say total number of ones equals to the sum of nums, right? Because you sum it, if there's a 1, you add 1 into it, so the total number of ones would just be the sum of the array. And then you can have a ones count equals to nums 0. So since you're starting at the first one, so that's how we do it. And then n equals 0. So now we're diving into the for loop. So for start in range length of nums. So this start is just the index from 0 to the ending index. And then we want to set that while n minus start. So n is 0 at the beginning. So while n minus start plus 1 is less than total ones, means the size is less than the size, and then we want to increment n. So in the beginning, n and start will pointing to the same. Maybe I can use this one. All right, in the beginning, start will pointing here, n will also pointing here, right? Start and n. But this is not our desired size. We want to keep increment. This is 3, right? So we increment until we find the desired size where we're pointing n here, and then start in the beginning. And then from here we count the 1, right? Every time we increment it, we have 1 count, right? So every time we increment it, we want to update our ones count. Ones count plus equals to the nums of n, right? But we need to also consider the fact that this n, when start is equals to the last one or anything from that. So let's say this is 3. So when start is here, we have another, well, our n is actually out of the index, right? So we want to make sure this is mode the length of the nums. All right, and then our mean swap will be equals to the mean of mean swap and the total ones minus the ones count. All right, there's actually one thing missing here. So the thing that's missing is actually when you're moving out the windows, right? When you're moving down out the windows. So now your windows is here. When you move out the windows, you want to remove this element from the count. Let's say now your count is 1, right? Your ones count is 1 for the first one. So when you go to the second one, now your ones count is actually 2. But when you move to the third one, you want to minus the 1 here and then plus a 1 here, even though it's still 2, but you also need to consider the fact that you want to remove it. So I will say if start is not equal to 0, means it's not the first index, is if index onward, you want to minus your count. Because when you're the first one, you cannot remove the 1 that's before you because we're using start minus 1. So when the first one you don't actually remove anything, but when you go to this, when you start is the next index, you want to remove the sliding windows, right? So at the end, you return mean swap. Typo. All right, let's run this, and then let's submit this. All right, cool. This will just be of n because it's just go through 1, and then it could be at most of 2n because if you actually have to append to array, but this can be just done in one for loop up to start. All right, I hope you enjoyed this video, and I'll see you all in the next video.